Alright, so today we're going to be going over the law of cosines. Monday we did law of sines, today is law of cosines. And here's the way you set it up. The law of sines, or I'm sorry, the law of cosines is when you have two sides and the angle in between the sides. It helps you solve for the third side. So if we look at this triangle that they give us right here, we want to solve for A. So you have to know the angle across from A and then the two sides around angle A. And you would set it up as A squared equals B squared plus C squared minus 2BC times cosine of A. So if side B is the one that you want to find and you know angle B and the two sides that make up angle B, then you would set it up like this. So it kind of depends on what side you're looking for, what angle you have. It has to be the side across from the angle that you know. Alright, so let's do an example. I was going to draw it here. So we have triangle FGH. Angle G is 82 degrees. Side F is 6, so the side across from angle F is 6, and side H is 4, so the side across from angle H is 4. That means that this side across from angle G is going to be side G. So I have my angle here and the two sides that make up that angle. I'm going to set up the law of cosines. The side across from your angle is what you're going to set equal to the other two sides squared. So I'm just going to write it out first of all. So h squared plus f squared minus 2 times h times f times the cosine of angle G. And then substitute the values in. H squared is 16. F squared is 36 minus 2 times 4 times 6 times the cosine of 82 degrees. Okay, so following the order of operations, we need to figure out what that 2 times 4 times 6 times the cosine of 82 is first, before we subtract it from anything. So I'm going to type it into my calculator. And I'm getting 6.680 blah blah blah. Okay, so I want to subtract that from the 16 plus 36. And it's good to keep all of the decimals so you'll have a better answer in the long run. You don't want to round until the very end. So what you can do, if you have a newer calculator, is you could take 16 plus 36 and then minus, you got to put your minus in there. I'm going to go up and retrieve that number, so you just scroll up and make the number highlighted that you want, press enter, and it brings it down for you. And then press enter one more time, and that is your answer. So the G squared is 45.31969, and it goes on. So again, so I don't have to write that down in its entirety, I'm going to need to take the square root of it. So I'm going to take second x squared, go up, retrieve that number. I'm going to arrow 1 over to get out of the root and press enter. So side G is about 6.7. You just wait until the very end to round it. Any questions? Now this tells you to solve the triangle, so that means I need to find all the unknowns, which means I can't stop just to find G. I also need to find angle F and angle H. Doesn't matter which one you solve for first. I can solve for angle F next. So in this case, since I know the side across from my angle, I solved that. Now I can use law of sines. So I'm going to set up a proportion using law of sines. Sine of 82 over the side equals sine of angle F over 6. And then I'm going to use my cross products and divide and get a decimal for sine of F. So let's do that. Sine of 82 times 6. I'm going to get that decimal and then divide that by 6.7. So your sine for angle F is about 0.886807, and it goes on. You guys remember how to find your angle measurement when you're given the sine value? Yeah, you got to use your inverse. So we're going to use second sine, and I'm going to go retrieve that decimal, close the parentheses, and my angle is about 62.4, or 62.5. We'll go ahead and round it to the nearest tenth. I think on your worksheet it's okay if you round it to the nearest whole degree. But for this example, we'll round it to the nearest tenth. So now I can find angle H by taking 180 minus angle G minus angle F. So I'm getting that angle H is about 35.5. So do all those make sense? Angle G is the largest, and then angle F is the second largest, and angle H is the smallest. I'm going to scoot my triangle down. Okay, since angle G is across from the biggest side, yes, that makes sense. Angle F is across from the middle side, and angle H is across from the smallest side. So yeah, those are all good answers. You do want to make sure that your angles and your sides make sense with each other. Any questions? Okay, let's look at the next example. Example 2. Solve triangle ABC if A is 5, B is 11, and C is 8. So here's A, angle B, and angle C. Side A is 5, side B is 11, and side C is 8. Okay, so side C and side A, they should have been switched, but it's okay. So when you have three sides, you need to solve for two angles using the law of cosines. We are not going to use the law of sines on this one, because if you use the law of sines, it can give you an ambiguous case, which you'll go over that more next year. So we're trying to keep it simple this year, and we're only going to use the law of cosines when they give you the measure of three sides. So it doesn't really matter what angle you want to solve for first. We just pick one, and then we're going to set the problem up according to that. So if I want to solve for angle A, then I need to use side A for it to equal. Excuse me. So I'm going to write down the equation. A squared is going to equal B squared plus C squared minus 2 times B times C times cosine of angle A. So A squared is 25, B squared is 121, C squared is 64, minus 2 times 8 times 11 times cosine of A. So I'm going to take 25 and subtract 121 and subtract 64. Let's see what that is first. And I'm getting negative 160. And then I want to figure out what negative 2 times 8 times 11 is. And for that, I'm getting negative 176. Okay, so I want to find the cosine of A, which I'm going to divide by that negative 176 on both sides. And I'm getting that it's about 0.9090, and it's kind of repeating, goes on. So to get my angle, I'm going to use the inverse button, and this is for cosine this time. So second cosine, I'm going to go up and retrieve that decimal, so it'll give me a better answer. And my angle measurement is about 24.6 degrees.
You would divide them?
What?
Would you divide cosine B by the 0.93?
You use the inverse button to get the angle measurement. Second cosine. Yep. Alright, so we have one angle measurement. Now let's solve for angle B. So since I'm looking for angle B, then I'm going to set it up so it's equal to side B squared. 11 squared equals 8 squared plus 5 squared minus 2 times 8 times 5 times cosine B. So you do not want to use the law of sines.
So you, like, I mean, would I give you a different answer if you use the...
It might, yeah. And so you can work on that some more next year when you have to say more, but this year we're just going to keep it simple. So that's 121 minus 64 minus 25, and I'm getting 32 equals negative, let's see, 2 times 8 times 5 is 80. So I'm going to divide by that negative 80, and I'm getting negative 0.4 is your cosine of B. Now I'm going to use the inverse again because I want to find the angle measurement. So second cosine negative 0.4, and my angle measurement, angle B, is about 113.6. So now at this point you have two angles, so you can go ahead and find the last one by taking 180 and subtracting those two angles from it. So angle C is 180 minus 24.6 minus 113.6. And I'm getting that angle C is about 41.8 degrees. And so angle C is across from the middle side, so that's going to make sense. Angle A is across from the smallest side, so that's your smallest angle. Angle B is across from your biggest side, so that's your biggest angle. Okay, you always want to check and make sure that they make sense. Any questions? All right, let's do one last one, and then I'll pass out your worksheet.
What did you calculate to get like that? Can you
Angle B,
angle A?
angle
You
A.
divided 0.9090 divided by cosine of
I didn't divide it. What I did was, when you're finding the angle measurement, you have to use your second function key on here. So you press second cosine and then type in your decimal, 0.90, whoops, 9090, and that gives you the angle. Okay? So when you're looking for your angle, oops, you can't even see that. When you're looking for the angle, use second function cosine or sine or whatever. Yeah. All right, so let's look at the last problem. They're going to kind of mix it up, and they're going to give you different problems, and you have to decide if you're going to start the problem using the law of cosines or the law of sines. So this is kind of a chart for you to help you figure out what you're supposed to do. If you have two angles and any sides, you want to start using the law of sines. If you have two sides and an angle opposite one of them, you want to start using the law of sines. Two sides and their included angle, you're going to use the law of cosines. If you're only given three sides, you're going to use the law of cosines to find two angles. You're not going to switch to the law of sines on this last one. You're going to use law of cosines the whole way. So let's read the problem. Example 3. Amelia ran 6 miles in one direction. She then turned 79 degrees and ran 7 miles. At the end of the run, how far was Amelia from her starting point? Turn this over. I'm going to draw an example of what she did. So it's always a good place to start when you have a word problem. If you can draw a picture to represent it, it might help you to organize the information that you're given. So here is Amelia's start, and she's going to run 6 miles in one direction, and then she's going to turn 79 degrees and run for 7 miles. So a little bit further. And they want to know the distance between her ending point and her starting point. And this angle right here is 79 degrees. Okay, so would I want to use the law of sines or the law of cosines? Law of cosines. So I'm going to call the side across from the angle side A. And it doesn't really matter if this is side B or if this is side B. Okay, as long as I'm consistent when I'm plugging stuff in. So I'm going to use the A squared equals B squared plus C squared minus 2 times BC times cosine of angle A. So let's substitute values in. I'm going to make B 6 and C is 7. I'm getting A squared is 68.97204439. And then when we take the square root of that, I'm getting that she is about 8.3 miles away from where she started. Is anybody getting anything different?